So we're here at the example table, and in this video, we're going to be looking to find the intervals on which a function is decreasing. In particular, we're going to find all intervals on which f of x equals 4 plus x over x plus 1 squared is decreasing. Now, we have a theorem that says if the derivative of a function is negative on a particular interval, then that function is decreasing on that interval. So we're going to use that theorem in this example. So we'll start by finding the derivative f prime of x. And we'll use the quotient rule, so the derivative of the top times the unaltered bottom. So we get x plus 1 squared, right? The derivative of the top is simply 1. And then we'll subtract the top times the derivative of the bottom. The derivative of the bottom is 2 times x plus 1, and then by the chain rule times the derivative of x plus 1, but that's simply 1. So that's the derivative of the bottom. Now times the unaltered top, all over the denominator squared. So all over x plus 1 to the fourth. Now we can cancel a few things. We have an x plus 1 in both terms in the numerator, and we have x plus 1 to the fourth in the denominator. So this x plus 1 goes away completely. This x plus 1 squared becomes simply x plus 1, and this x plus 1 to the fourth becomes x plus 1 cubed. So we can rewrite this as x plus 1 minus 2 times 4 plus x all over x plus 1 cubed. And if we simplify the numerator, we get negative x minus 7 all over x plus 1 cubed. So here's our derivative, and we want to find out where this thing is negative. So let's do that on the next page. So let's write the derivative once more. It's negative x minus 7 all over x plus 1 to the third power. Now this is a ratio of two things. A ratio of two things will be positive if the top and the bottom are both positive or both negative, and it will be negative if the top and the bottom have different signs, right? If one of them is positive and the other is negative. So let's figure out where the numerator is positive and negative and where the denominator is positive and negative. So for negative x minus 7, let's draw a line. Now this is a nice polynomial. The only way that it can go from being positive to negative is if it crosses the x-axis somewhere. In other words, where it's going to change from positive to negative or negative to positive at some point where it's equal to 0. Right? That doesn't have to happen in general for a function, but polynomials are really nicely behaved, so it always happens for a polynomial. This thing here is 0 when x is negative 7. So let's put negative 7 on this line here. To the left of negative 7, this thing is positive, right? If we plug in, say, negative 8. Well, negative 8 is positive 8 minus 7 is 1. So this thing is positive. Negative x minus 7 is positive for values of x smaller than negative 7. And similarly, it's negative for values of x larger than negative 7. So here's our little sign chart for negative x minus 7. Let's make one for x plus 1 quantity cubed. This is also a polynomial, so we know that we really only need to worry about intervals created by finding the zeros, right? The zeros here, well, there's only one at negative 1. So it can only change sign at one point, namely negative 1. Well, if we plug in a value, let's say negative 5 somewhere on this side, we're going to get something negative in here cubed, that's also negative. And if we plug in something larger than negative 1, let's say 0, we get something positive in here, and something positive cubed is positive. Now, we want to take these two sign charts and combine them to give us the sign chart for the derivative. So remember, this quotient is going to be positive if both signs are the same, and negative if both signs are different. So on this chart, we're going to need the 2 points from our previous charts. Now, for values of x smaller than -7, this one gives us a positive, this one gives us negative. Positive over negative is negative. Between -7 and -1, well, the top one is negative and the bottom one is negative, so it gives us positive. And greater than -1, we have negative and positive, so once again we get negative. So we have two intervals here on which the derivative is negative, from -infinity to -7, and from -1 to +infinity. So the question is, on what intervals is f decreasing? Well, this gives us as I said, -infinity to -7, and this one gives us -1 to +infinity. But notice that I didn't put anything next to -7 or -1. I didn't close this one or open this one, because we have to figure out whether we put brackets here or parentheses. The easy one in this case to figure out is -1. The reason being that, remember, f of x had x plus 1 squared in the denominator. And if x equals -1, x plus 1 is 0. So that denominator becomes 0. So -1, let me write down, f of x, remember, f of x is 4 plus x over x plus 1 squared. So -1 is not in the domain of f. So we certainly can't talk about f increasing or decreasing at -1. But -7 is fine. -7 is in the domain of f. But the derivative of f prime, is 0 at -7. So you might be tempted to say that it can't be decreasing at -7 because the derivative is 0. But our theorem only says that if the derivative is negative, then it's decreasing. It doesn't tell us what's going on when the derivative is 0. And in this case, imagine the original function. It's decreasing on this interval. So imagine it's doing something like this. Well, let's sketch something. It's doing something like this. It's decreasing, 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 and then it hits 0 at -7. Well, by the definition of decreasing, all we need is that at -7, well, the function takes on some value like this. For a smaller value of x, we get a larger value of the function, right? That's what it means to be decreasing. So -7 fits this definition. Let's say maybe, I don't know, -9, for example. All right, if we make this -9, it's going to be larger. So -7 fits the definition. So we include that in this interval. So our answer is that f is decreasing on the interval from -infinity to -7, including -7, and on the interval from -1 to infinity, not including -1. So if we remember nothing else from this video, remember, well, of course you should remember many other things from this video, but one of the things you should remember from this video is that we don't talk about a function increasing or decreasing at a single point. We only talk about functions increasing or decreasing on an interval. So the fact that this derivative is 0 at -7 doesn't mean that the function is neither increasing nor decreasing at -7. We don't talk about something like that. We talk about, say, the function increasing or decreasing between -9 and -7, or on the closed interval from -9 or -7, something like that. We do not talk about increasing or decreasing at a single point.